Hello, you're welcome to my class on Research and Statistics Guide. My name is Dr. Felix Ayodele Oyeleye. Today I will be talking to you about sampling. Now, usually when we conduct research on population, many at times it's difficult to work with every element in that population. Or sometimes it becomes impracticable, maybe because of the size of that population, maybe because of the costs of working with the entire population. It becomes necessary to obtain sample from that population and understudy that group of sample we have obtained, and then whatever findings will come up from it, we generalize it to the entire population. So this is where the concept of sampling comes from. So the big question is essentially what is sampling? So sampling becomes the procedure by which some member of the population are selected for the purpose of representing the entire population. And what is the objective for obtaining sample from a population? Now, we want to make sure that we can draw inference from that small group that we have obtained from the population of interest, and whatever findings we came out or will come out from that comes out from that particular sample, we can generalize it to the entire population. For instance, if we are to work with the entire Nigerian youth, it is practically impossible to reach every youth in the nation, across the nation. So we may have to take a sample of youths, interact with them, make certain findings among this sample we have obtained, and then whatever findings we got, then we generalize it to the entire population. So that is the objective for sampling. Now, usually we have two possible ways survey can actually be conducted in a population. There's what we call exhaustive survey. An exhaustive survey is otherwise known as total sampling. A situation whereby you want to conduct like a census. You want to count the entire people in a province, in a state, or maybe even in a nation. So that is what we call exhaustive survey. While on the other hand, as we have been discussing, it is important sometimes, or it is necessary sometimes, to pick samples from a population for the purpose of studying. So if you are to compare the two sort of survey, the exhaustive measures every individual, while sampling will just pick a subset of individual from that population for the purpose of studying. And then the information we obtain from exhaustive survey, or call it total survey, is usually the true population value. That is what we describe as parameter in statistics. While on the other hand, the information, the statistic we get from the sample we have obtained from the population is usually described as estimates, their estimated value, or we call them statistic. So for the entire population survey, which is exhaustive survey, no confidence interval is usually required. But more often when we deal with a sample, which is a subset of the population, we can only express our confidence within a measure as regards the value we have obtained from that particular sample. In other words, it becomes a probability. We cannot absolutely guarantee that what we have is 100% correct because we are dealing with a sample obtained from a population. So the question again is, why do we sample? Number one, we are gathering information from the larger population using smaller number of people, and then we want to use it to draw inference about the entire population. So again, we have compared our sensor with our sample. In the case of sample, it is much cost effective. You can do sampling with a lower cost instead of conducting a sensor. And at the same time, it will also cost less time, and it will also require fewer resources. Now again, it is reasonably accurate. More importantly, we follow the principle of sampling. Now, there are two approaches to sampling. There's what you call the probability sampling. We have the non-probability sampling. Probability sampling is based on statistical theory, while non-probability sampling is not based on any statistical theory. Okay? So usually under probability sampling, we talk of random selection of our subjects. It simply means our judgment does not influence that selection. We don't allow our bias to play a role in the course of selection, but we allow the process of randomization to guide us in selecting representative sample even from that particular population. While on the other hand, the non-probability sample does not use random selection of subjects. Many a times it could be based on convenience, or it could also be based on availability. Okay, so for probability sampling, we use probability sampling more importantly when we want to test hypotheses in research. While the non-probability sampling, it is often used we can use it um, to come up with an hypothesis, but not necessarily to test an hypothesis. Probability sample, we test an hypothesis with it, but non-probability sample, we can use it for formulation of an hypothesis. Okay, so now let's quickly look at a few terminology associated with sampling. Number one is the study universe, and also we otherwise refer to it as sampling universe or target population. For instance, we are talking about if we are to sample pregnant women in the entire nation, okay? The entire population itself is the big population. But of course, we are not interested in everybody in the entire nation. We are interested in pregnant women. So it means that every pregnant woman in the nation is our target population. So that is what we describe as the study universe, the sampling universe, the target population, or our source population. And that is the population from which we want to actually pick our sample. Of course, we are studying the entire pregnant woman, but we cannot possibly reach every pregnant woman across the nation. So we have to take a sample from it. So we have the target population from which we obtain our sample. Okay, so again, we have other terminologies that we must be familiar with that are associated with sampling. We have what we call the sampling unit. These are the entities. It's the entities that make up our sampling process. Okay, individual pregnant women is the unit of our sampling. And we also have what we call the sampling fraction. The ratio of the sample size to the sampling universe is what we describe as the sampling fraction. For instance, our target population. If our target population, say we are dealing with Nigerian youth, if entirely the Nigerian youth are like, say, 50 million in numbers, and out of this 50 million, we've been able to calculate a required sample size to use for our study, and we arrive at, say, 5 million. Okay, so that 5 million is our sample size. To obtain the sampling fraction, we divide the the sampling universe by our sample size to get our sampling fraction. Okay, so the sampling size divided by the sampling universe becomes our fraction. And of course, the people that are going to fill out our questionnaire or they are going to participate in our survey are the people we refer to as a respondent. Now we have the survey subjects, which is the individual person from which we also collect our data from. Okay. Now, Probability sampling methods are of different types. Basically, we have 5 types of probability sampling method, and we're going to try to touch just a few of them at this moment. Subsequent class, we're going to cover the rest of them. So the first one is the simple random sampling. This is the basic sampling technique, okay, through which we can obtain sample from a population, and it involves choosing number at random, even from our population. Okay, we have obtained our sample size. Now to pick the required number of sample from the population, we have to adopt the principle of randomization. We don't have to allow our bias to come in. We allow nature, okay, to guide us in picking the observation. So, and there are several ways we can do this, which I'm still going to explain. The second type is the systematic random sampling, which involve picking every nth term or the nth entry of a list that we have actually chosen from our total, the sample universe, and then we pick our sample size even from it. Now, we also have the stratified random sampling. Now, more often we deal with, sometimes we may be dealing with a population that is divided into strata, maybe based on age or maybe based on gender, based on status and different things. And in fairness to that population, if we are to pick a sample, it is important we address every interest in that population. So when you have a population that is divided into strata, it is important you use a method like stratified random sampling. For the simple random sampling and the systematic random sampling, they are most appropriate when you are dealing with homogeneous population. For a homogeneous population that is very small and moderate, you use simple random sampling. But for a homogeneous sample population that is very, very large, you're most likely going to be using systematic random sampling. While the stratified random sampling will be for a population that is naturally divided into strata, maybe age, maybe gender, maybe status, academic qualification, and what have you. The idea is that there should be evenness. Every element in that population must have equal chance of actually being selected, even as part of our sample. Now, the third type of sampling technique is the cluster sampling technique, okay? And it's also built on the simple random principle, okay? But it's a little bit different in the case of cluster sampling. Cluster sampling, many a times, is most applicable when we are dealing with a population that you have different group scattered, a kind of scattered population clustered together in small, small group, maybe like villages. You can have villages, remote villages, and all that with varying population size. And many a times they are far apart. So cluster sampling becomes appropriate for such a scenario. So, and of course, the last type of probability sampling is the multi-stage sampling. Of course, in this case, we're going to be using different level of sampling. Different level of sampling we're going to apply among the previously mentioned type of sampling. Okay, so for the simple random sampling, the principle is based on randomness, randomization. We randomly pick our sample. So there's a non-zero probability for every selected sample for each of the units in that particular site. It means each of the units of the sample has a probability of being selected. And the procedure will start by number one, you have to list the entire individual in that particular population. And that is where our sampling frame comes in. Before conducting a simple random sampling, we have to list every member of that particular population. And sometimes we have to assign number to each member, each item, each element or unit of that population. And then we can now apply random number for selection. And it is quite a very basic type of sampling technique for most researches. Okay. So we have looked at the principle. We are now going to look at the procedure. I've talked about the procedure. We list the individual and we use random numbers. There are different ways we can conduct the random selection. Maybe we are using balloting system, the computer generated random number. There are several methods that can actually be used to conduct our simple random sampling. Okay, so for instance, say we are to conduct a survey, maybe in a clinic, and our sample size is 50. Okay, and then we'll be using the clinic logbook. The first thing to do is to assign random number to every patient, probably that have ever visited that particular clinic, from which we want to select the 50 patients of interest. Okay, so I've said we could use different methods in randomly picking this sample. Either we use table of random number as we have it on the screen, or paper slips in a bag or hats, or computer generated random number. So whichever method we decide to settle for, so we have to decide it first and then we conduct the survey. Now we have an example on the screen. For instance, if we are to pick a sample of 5, that is a sample size of 5 from a population of 10. Okay, we have calculated our sample size and we have arrived at 5. Now we have to pick it from this particular population, target population. The first thing, if we are to use a random number table, so we randomly pick, select a series of a serial number. Say we pick the 76482. So the implication of this is that 7 will be chosen first, followed by 6, followed by 4, followed by 8, and followed by 2. So that is a simple random technique system. Choosing 5 individual from a group of 100. So while the systematic random sampling actually is a little bit similar to the simple random sampling, but it is different in the sense that it is most applicable to, of course, a homogeneous population, but very large population this time around. Usually when you have a moderate population, the simple random sampling may come in handy. But when the population is considerably large, even if it's a homogeneous population, you may have to consider using the systematic sampling technique. So and what we have here now, you have the units drawn from equal interval. You have to first of all calculate the sampling interval as we have on the screen. So how do you calculate the sampling interval? You divide the target population by the sample size you have actually calculated. The sample size is represented as small letter n, while the sample universe or the target population is the uppercase letter n. So when you use your random number, you can now use your random number to pick the first units from any number less than the sampling interval you have calculated, that is less than k to begin. So when you when you pick that, then you will now select every kth unit. In other words, for instance, if our sampling interval is say 5, it simply means we are going to pick use a random sampling number to pick from 1 to 4. So and when we pick whichever one that it falls on, then we are going to add 5 to that number to get the first unit, to pick the first unit. So the systematic random sampling, of course, also follow the concept of randomization. So we have an example here. Say we are to take a sample of 5 persons from the same group of 10 persons, and we're using systematic sampling technique. We still have our random number table to be used. We have calculated our k, that's the sampling interval, to be 2. So when we randomly select, okay, through random selection, we have picked three. We have picked three. So the next will now be what? We add two to that particular first letter. When we add two to it, it becomes five. Then 5 will be the next one to pick. We add 2 again to get 7. We add 2 to get 9. And then we keep adding 2 until we get the needed sample size we have actually calculated. So that is the way to calculate for systematic sampling. Apply the systematic random sampling technique. I believe you have gained one or two things from this presentation. Join me once again in my subsequent class as I share with you ideas that will help you in your research. Thank you.